Hello everyone. This is the continuation of the walkthrough of the stock market prediction project case study. I left on the last slide where the code walkthrough started. So this is a brief glimpse on the final and the main notebook, which actually runs the uses the stock master and prepares the model and then finally predicts out of these models. So what this really contains, so I have given a very high level picture of this one here. So the stock master details here on the top, which says stock daily numbers, and the next one is the stock technical details and analyst rating and the new sentiments which we did in the earlier steps. So what this guy does is it fetches on the live connecting to the Yahoo API the next 7 days for validation. And the next thing here is I have defined 3 different functions here. The first one prepares the data, it applying all the methodologies, converting it to arrays and all that stuff, builds the stepwise, restructures the data so that it can be fed to any RNN model. And the next one, the function 2 here, builds the models. So as I spoke about the earlier during building the statistical model, so after all my trial and errors and looking at the loss, I built this function, and the last function is the predict plot, which takes the model output and then runs the prediction versus the actual numbers. So just to make a note of it here, the data prep, all these, the first 2 functions are dynamic in the sense they you can feed any ticker and any set of data to prepare the data, and then the second one will take the output of the first one and then build the model on top of it. So basically the entire functionality here is dynamic, so that you can run it for any ticker, any set of data. And so while again when I talk about any ticker and stuff, there are 4 different feature sets which I'm going to talk about in the next slide. Okay, so here these are the steps overlaid on what do I do there? Loading the stock master, loading the ticker list, and building dynamic functions. So the functions which I'm speaking about. So on the bottom here we have the feature set. So I'm not running the entire model against all the features. I'm conditionalizing the features. I'm choosing only the technical features once, this technical features and the analyst ratings, technical features and the new sentiments, technical features and all the data set at once. So basically, and then I have 4 different models. I built 4 different models so that I can use one of these against one of these. So totally, if you want to run, you can run 16 different combinations for a single stock and find out which is the most effective model, whether the stock technical features against the group or stock technical features against the mix model, which is the LSTM and group, or when you add and how the same prediction is behaving when you add analyst ratings. You can try and check all these models, everything is available, and I have explained the code comments as well to understand what I have coded. So the next one would be, so I've tried to give at least 9 iterations, 9 of these combinations inside for any stock. So this is some of the sample data not the sample data, this is the prediction data for the stock, which is modeled against the stock tech features, only the tech features, and the mix model, which is the GRU and the LSTM. So here what we see is the yellow line goes across, which is the training prediction. So my model is predicting pretty close to how the actual stock price is. So this means that it is taking really well. The model has learned really well from the data. And then finally, when it comes here, we are trying to see the red line here is the next 7 days prediction. So this is 2 year worth data which starts from August 2018 until the July 2020. So I have tried to give a very close picture of what did my model do, what was the actual price. So this is a 7 days actual price, and model says that it goes in 360. Not very close, but not very bad. And this is the another example where Bank of America stock prediction, the stock tech, where I'm using the stock tech and analyst features against the GRU model. So here I'm pretty close, where it says my model says that it is going to be somewhere between 24 to 25, and the model is somewhere on the 25, which is not really bad at all. And a similar one for the same one, showing the entire 2 year worth learning and then the prediction, and so on and so forth. So let me quickly jump onto the code and go through the entire coding notebooks. So let me quickly go through the Jupyter notebooks. So here are my 4 steps involved. So the first 3 steps are data collection and cleansing, and then preparing, and then merging it into a stock master. So I'm not going to take too much time on the first 3 steps. What I do here is selective stocks from Yahoo Finance for 2 year worth data. So I connect to them and then fetch all the data. Then the same thing continued here, 10 selected stocks for the past 2 years. And then now I add the analyst recommendation for the same selected stocks. And finally what I do is, using this analyst ratings, I prepare a rating lookup and then classify the rating words as numbers, in the sense if there is a strong buy, the number would be like 7 or 8. If there is a poor or overweight or stuff, then I'm gonna give a lower number. So then finally I have used the S&P and Dow, and brought all those things together, the analyst rating, the S&P Dow, and the stock market data, entire thing in one, so that we can see how the stock is growing alongside the market indexes. And then in the next step, I am loading the Kaggle data set from the which was available for CNN, Reuters, and the Guardian. What I did is I have used the code. Most part of the code is also taken from the same Kaggle website to calculate the sentiments of these news headlines and the predictions. And then this is also pretty useful for our study. Then the next thing would be merging the step 1 and step 2 data into one. So I'm not going to go deep. So this step actually is pretty intensive, and I try to bring as clean data as possible for the final step. So the final step, since we already spoke about the high level here, let me go through a little low level details here. So we load the data. What the stock master contains is this stuff: loading the libraries, loading the master stock file, which contains all the news, analyst rating, stock details, and this is a glimpse of what it has right now. The date, open, close, adjusted, volume, the simple moving averages, percentage change. Then we have the industrial averages. Then we have the analyst ratings, and then finally the news sentiments. So let's move on to the next one. So we are getting the next 7 days data here. Then finally we have defined 3 functions as we spoke about, and these are pretty dynamic functions. So how do we do is, what the first function does is it organizes the data, scales the data, and creates a time step level to consume for the RNN. So this guy takes the main file, in the sense the master stock input, and then the features, what features you want to run, and then the output 7-day prediction as well. So what am I doing here is for every feature they select, I'm giving only specific features so that you don't have to use all the features and inflate your model. You can only use the selected features and then study the behavior of the stock price. And this is the entire part of the data restructuring. Then let me move on to the next function. So here I have built the function. So here again I have conditionalized it using the dynamic inputs. We have the training data which is prepared from the previous function, and then I take the steps, how many steps I need to go back and prepare and have this model. And then we have the data set train, which is the original data set, and then what type of model you want to choose. So I have the LSTM with two hidden layers, and then I have a GRU, I have a mix, and then I have a complex. And then finally I am doing some more cleansing, and then we fit the model here. We fit the model here, and then we have the plot loss and validation. So this function gives me the model summary as the output. So the last one, which takes the prediction, generates the prediction and plots the actual versus predicted values. So here I'm taking a lot of inputs here, bunch of inputs, and giving the prediction, trying to predict based on what model was built in the last. So, and here we plot the comparison stuff, and then the actual versus the predicted 7 days. Let me move on to the next one. So now we apply these functions to any stock in the current data set. So let's study each of these stocks from the different feature set and different RNN. So what am I talking about when I say different feature set? You can choose one among these, and then when I'm choosing different models, you can choose one among these, because everything is dynamic here. And then finally plot the results. So 3 functions. Now let me take Apple stock prediction. So now I'm doing only based on the stock technical features, which is only the tech. It does not involve the technical rating or technical news and stuff. The stock news and stuff. So let me open the stock tech features only. So here I have, let me show you, there are 3 models. I have LSTM, mix and GRU model. So let me go to the GRU model first, the third one. So I'm calling these functions here and capturing all the outputs here. So I'm calling this function, passing this, and then passing the Apple ticker, and then I'm saying only the tech only, which says the stock technical features only. Now the next thing, I'm taking all these outputs from the first function and then passing on to the next one, which and mentioning that I want to use the GRU model here. So and then I use this output and feed it into the predict plot, so that I can get all the plotted outputs. So here at every step, the output determines what's going on, how my model is performing. It says data preparation start, data preparation end, RNN model start, and this says the GRU is running, and then this is the model how it ran, and then we are very good at the validation and the training loss. So this one here, it actually predicts based on the GRU model, which I found the most effective one, how my training and the actual is going on. Then finally I am trying to plot what is that, where do I stand in terms of comparing the 7 days data versus the actual price. So here is my comparison, and here also it stands, it says around 360. So it's here also it is saying about 360, and the actual price has gone up to 420, and this is because of the outstanding quarter result for Apple, and the share price has gone really high. And so the same thing, I'm not going to explain each and every one here. So the same thing, the stock tech features against the LSTM, the mix model, and now I have done it for like Apple, the three feature set and 3 models. and Tesla 3 feature set 3 models, Bank of America 3 feature set 3 models. So I tried to give a most simplified way. You can add any stock here, just you need to change. So if you want to change, you just need to change this ticker value here, and if you want to choose a different model, you can just choose a different model and then observe the data set. And based on this, the GRU and the mix model is one of the best performed models. And finally, ending this stock market with the limited data set, I have tried to do my best and applying the RNN methodologies here. But it's again, there are many parameters which I have listed out here, so that I can get we can get to that when we have time. So adding Twitter sentiments, deeper financial scores, changing P ratios, EPS, investor updates, and scraping the Finviz or company sites for key notifications. If we add more of these features, then we'll be very close to how the stock is moving and the best prediction algorithms to live with. Thank you for listening. Thank you so much.